So I'm going to start. We are going to get to the live demo, but first I wanted to warm you up with a few slides. And I initially started this, we weren't sure of the audience and how familiar people were with NSM. So we're going to very, very quickly go through some general stuff about NSM and how VPP and NSM are a very good match together. So, and my focus is, maybe it's me as an individual, is really core CNFs, in other words, network functions themselves, and particularly network functions for the telco industry. So NSM is very good for NFE, and it directly supports network-focused workloads. And the networking payloads are not an afterthought, and it plays very well with Kubernetes. And also, IFs are injected directly into the containers. So we like to think of networking as a service, and so the NSM creates connections and the network service between network service clients and network service endpoints. And again, the challenge that we're trying to solve is both the changing world of application software, which is maybe perhaps better solved with, in some cases or many cases, with standard networking in Kubernetes. But when we're looking at the telcos and service providers, they want to take their network intensive workloads and move them to containers and Kubernetes as well. And that's where we can help them a great deal. And a very good example is, for example, in the 5G space and 3GPP, and with the radio access networks. So we have to support co-located multiple services at the same edge of the network with combined routing and bridging functions and services at both layer 3 and layer 2 with different SLAs, different service level agreement. So how are we going to do that with standard Kubernetes networking that just has this sort of large, undifferentiated IP space with IPs provided to the container and mapped into their space? And they're just not, they're designed to make networking simple, not to solve networking problems. So a very good connection is with millimeter wave radios, and the idea is that with the very, very high bandwidth that you need for mobile, you change the frequency that your carrier is, which makes it more directional and less able to bend around obstructions. So the idea is you have an ambulance you're talking to that's running through a city, and you may actually have to switch towers with emergency high SLA traffic while the vehicle is moving. That's just one example. So what are we going to use to do this in containers, in Kubernetes? So a more specific example, and I'm going to go through these slides very quickly because I think you all really want to see the demo. So containers can hold each of these, what we call these network slices, which are pieces of the network partitioned in such a way that each is provided with a different SLA, different latency requirements, and different bandwidth requirements, depending on the type of payload. And so the challenge is to provide them all simultaneously at the same physical location, if you will. So this is very difficult to do. In this slide, we can see how that this example was cribbed from the 3GPP paper, and we can see that some of the many different kinds of challenges that we're going to have. And so if we're going to try to do this with just a very simple example of how we might do this with network service management, we have a pod at the end of the network. Let's just take one slice, and it's providing an IoT slice for a mobile vehicle, for instance, that needs a lot of data, otherwise it might crash into something. And so this negotiates its own connection. So each network slice, each consumer of the data will negotiate their own connection. So again, these consumers are network payloads themselves, in other words, implemented as containers in perhaps the same pod or different pods. So Kubernetes network just doesn't solve the problem. And another thing is that, another example is that Istio, which provides a somewhat smarter layer 7 connectivity, but it is layer 7. It does, and it does not really deal with or help you deal with layer 3 and layer 2. Multis expands with providing a separate or multiple address spaces by using additional CNFs. But the semantics really aren't there to define the nature of that connection. And some of that, I think, in examples that are being done now, some of that's hard-coded. And one of my very gifted colleagues I work with is working hard on the Multis project, and I'll probably get that stuff beaten out of me. But nevertheless, it has some limitations that NSM doesn't really have. So NSM was kind of inspired by Istio and experimental networks, but it applies these directly to networking. And there's a pointer here to some other slides that you can see that it explains this in much more detail with the narrative example. So, and as for VPP and why VPP and NSM are almost as if they were designed for each other. So VPP both provides, as we know, we heard about all morning, fast performance, a very rich feature set from a networking point of view. And it also provides, really critical, is the MEMIF interface that will allow you to do mapped transfers of packets directly without copying, directly in from one container to another or from the base into the container. And all this allows us to extend very, very fast networking into the container space. And now we're going to get to the bridge domain example. And so we're going to see how the bridge domain uses an NSM data plane abstraction, and it uses the VPP agent to manage the connection directly with VPP. And the VPP is the data plane in this example, and I'm going to turn it over to Frederick at this point.
Hello. So I believe an appropriate offering has been made to Ian, roast beast. Great, so let's get started. So we're going to start first by taking a look at kube control and looking at Kubernetes. So we have no pods that have been deployed. So we're going to start by deploying our network service mesh infrastructure. So we'll let that run in the background. It takes about a minute to spin up all the pods. So to get started, so hopefully this is large enough for everyone to see. Can you see it in the back? Excellent. So what we're going to do is we're going to get started by looking at a network service endpoint. So this is something I've copied over from the ICMP responder. So we're going to change this to be a bridge domain. So we can actually submit this and it should just work, but we want to do a little bit more than that. The magic typically happens in this network service endpoint connection. So new connections will come in, and this actually is backed by a gRPC service. So a new connection will come in, and you handle each of those connections through the service that's created behind this new. So as you can see, there's a VPN agent network service that's created from this new. So what we're going to do is we're going to say this thing needs a bridge domain. So we'll start off with an L2 bridge domain, and we'll go ahead and make a variable out of that, and we'll add in a name. So I like to call my bridges during talks Jeff. So we'll go ahead and change these over to true. So we're going to say flooding is true, unknown, unicast flood is true. We're going to turn on forwarding and learning. Leave ARP termination by itself. Just give it a MAC age, 120 minutes, actually more than long enough. For interfaces, so this is where it's going to store the interfaces that we add onto the bridge domain. So we'll tell it to right now make an empty list of bridge domains, and the rest will just destroy. So we now have a bridge domain that we're not using yet. So we're going to add to this network service structure a bridge domain. And so it doesn't exist yet, so we'll add that in. So we'll create a field. We now have L2 bridge domains that are part of that now. Oh, so now that we have that added into the structure, we'll do create bridge domain, which also doesn't exist yet, so we'll go and create that. So what we're going to do with this one is we're going to make a function, and this function is going to return a data request. So this is data request is a VPP structure that you use to make any changes to the underlying VPP system. And this function is going to be submitted to a little thing that I wrote in order to actually run whatever change is requested. So we'll go ahead and wire that up to be ran. And what we're going to do is we're going to say RPC data request, and we're going to say that this has a bridge domain, and that bridge domain is going to be list of bridge domains, and we're going to pass in the bridge domain that we just created. And we'll add a variable to that, and we will return that request. So now we have so this is everything we need to actually create the bridge domain, but we still need to wire it up to something. So the actual service itself, the thing that gets called is going to be this create VPP interface. And this create VPP interface from the ICMP responder just basically creates an interface and then returns it back. So you have a point-to-point connection between this and whatever is connecting to it. So instead, we're going to hook it up to the bridge. So in order to create it to the bridge, first we need to get the interface out of the data change object that was created. So we'll say new interface is equal to data change. We'll get it from the interfaces. And we need to get the last element. So this gets the length of the data change interfaces -1. That gets us the new interface. Then we'll say the bridge domain interface is going to be equal to a new bridge domain interface type. So we'll go ahead and we'll fill this out. And we're going to take the name from the one that was just created and add it in there. The rest we can just use the defaults. So we're not going to change the horizon group or any of the others. So this gets us the interface itself. Then what we're going to do is we're going to get the bridge domain, and we're going to append this bridge domain or the interface to the bridge domain. Let's see. So it's saying I have an error. What it is this needs to be a pointer. So it is now a pointer, or a reference rather. So now that we have that added in, the last thing we have to do is add to the data change the bridge domain. So with that, we've now wired up the bridge domain to VPP. So this should be enough to get us a bridge domain working. So let's make sure we don't have any errors. So we'll build it, see it work or fail. It takes about 7 seconds. Okay, so it worked. So what we will do is we will build a container. So I've taken the liberty of writing up the make infrastructure just to build the container in this one beforehand. So. Also, I need to ask, can you see in the back with this size as well? Cool. And while we are waiting for that to run, we'll also get the port number for Skydive. And Skydive is a nice UI that you'll see what's going on. So we'll wait for it to connect. Expand it out 1 level. And so we have Skydive. So you see right here, there's four pods that are started up that are connected to KubeWorker. So what we'll do is we'll deploy our bridge domain, and we should see a new bridge domain pop up in a few moments. Once it's done, let's wait for this to finish loading. So we see it's popped up. And now let's go and attach some clients to it. So before we attach the clients, though, I just want to stress, this is the ICMP responder. And this is the bridge domain. So the only thing I changed is changing ICMP to bridge responder and selecting the actual bridge domain application itself as to what it should connect to. So this is just running Alpine, unmodified. So let's go ahead and add the Kubernetes, this particular definition. And we'll apply that. And we should see in a few moments, they're popping up. And now we see that we have 4 connections because there's 4 replicas that are in that list. So we can, let's make sure that that all works. So we'll get pods. We'll see that there's 4. They're all running right now. So let's go and jump into one. So part of the ICMP responder is it automatically gave them an IP. So let's make sure that an IP was assigned. So C1030.11/24 was assigned. So let's make sure that you can ping 1.2. You can ping 1.3. And you ping 1.4. So we can see that based on this, we've actually have connected to each one. Let me refresh this so it gets nice separation between the both of them. There we go. So, so what's going on? You can see right here that the connection that was made, you can see like this particular one is making a connection with the IP 1030.14. And you can see via, in this scenario, is VXLAN with the mechanism type. Sorry, it might be a bit small. See if I can make it a bit larger. And I'll scroll down a little bit. So you can see VXLAN is listed here. Mechanism parameters VNI is 4. So this was automatically negotiated. And since we have 3.5 minutes left, I'll show off one more thing. So let's say we're ping 1030.15 and we'll just add one more. So controls get deployments. So we'll get the name of it, that's NSC bridge domain. And we'll do kubectl scale replicas is equal to 5. And we need to add deployments to that. Replicas, sorry. And so in a few moments, we should see the new pod come up, and then you should see this pinging. So you can see the 5th one's come up. Again, auto-negotiated and everything. So I think we have about 3 minutes left. So I think we have enough time for questions if anyone has. Ian.
I have 2, and they're mostly not evil. Mostly. So, question number 1, that was a whirlwind tour. How much of this you actually written down?
How much has been written down?
Yes.
So my next task is to create a blog post of this so I can write it down and show it off. And also, if you're talking about architecture as to like how this particular thing works, so we're in the process of documenting how a lot of this works. So we've been in a race to get things out and actually show off what we've been working on.
Yeah, because I think they're in the middle. I mean, given that nothing you wrote touched VXLAN, then you kind of threw something in the middle of that demo that I think was unexpected. So that's why I'm saying the documentation might be useful. The other one is if I wanted to build a network service all of my own that does weird and wonderful things, how much of that have you written down?
So what I'm going to do is part of why I constrained this to 6 minutes for the demo, why this is a really good venue, was that if I need to find what the right what is the right level. Like I need to show stuff that we automatically provide. So things we want to be able to provide automatically is things like you're using a kernel interface, or you're using memIF or vhost user or so on, and to be able to auto-create those and land them in a very easy-to-use way. What's that? And so I think that in that scenario, we want to provide an SDK to make this very easy, so you just plug into the right hook.